So Unit 2.1, the first part goes through motion basics, which is introducing us to the basic concepts that we're going to use throughout the year to make predictions. Remember, physics is all about the ability to predict what's going to happen. Okay, so we've talked about in class, we talked about a golfer. If we're going to have a golf ball and we have, our flag here, how can we know which club we need to swing with in order to project that ball and to land right next to the hole, right? How do we predict with that? And what we're going to do is we're going to try to learn the mathematics behind how we can make those predictions. Or think about earlier in the year when we had a boat and there were two other boats, an upside down boat. We had two other boats and, we had a cannon that shot at both boats, and it talked about I think it was the other way, actually. We had one that shot here, and then we had one that shot here. And how can we predict which boat is actually going to get hit first? So if we can understand some concepts and some simple mathematics, we're able to make predictions. So some of the concepts that we're going to go through is first something called position. And for the most part, position is simply your location at any given time interval in reference to something called an origin. Okay, so in this instance, we might have our origin right here. This is our position equals X, and we might have our golf hole 120 yards away. Okay, same thing here. In terms of a number line, this might be our 0 position, and then we have position 1 and position 2 in terms of where those ships are. Okay, so for us, it doesn't matter where our origin is. We just have to define where it is. And our position is where we are in reference to that. And again, we're going to measure this in meters when we're talking about motion. The next concept is distance, which distance is something called a scalar, meaning we don't care the direction that it travels. We simply care about the total length of the path taken. And then the next concept is displacement, and displacement is a vector. And we haven't talked about vectors yet, but a vector has three things. It has a length, it has a unit, and it has a direction. Okay, whereas a scalar only has two things. A scalar has a length, and it has a unit. Okay, so the main difference between something that is a scalar and a vector is that a vector worries about the direction and a scalar doesn't. And for vectors, we're always going to indicate with an arrow, right? This is my length from head to tail, the tip, so that's my length. My unit is depending upon what type of vector it is, and then obviously the direction is going to be based upon the direction that arrow is pointing, okay? So distance and displacement are different things, but they can be the same. They're going to be the same when we have an object that moves from an initial position to a final position along a straight path. So if the path that I take is simply walking from there, then if my initial position maybe is -2, here is going to be my 0 position. Let's not put it there, it makes it look like 20. If this is my 0 position here, and then maybe my final position is +3. My distance that I traveled is going to be 5 meters. My displacement is going to be +5 meters. Notice the difference is one gives me a direction and the other doesn't, okay? That would be, now if I walk back the other direction, the green line, then my distance, let's do it in green. Ooh, I don't like that green. Let's get a different green. My distance would still be 5 meters. Now my displacement is going to be -5 meters, okay? And when we look at this, we see this delta x, okay, a triangle x. And delta always means change, okay? And when we have that, we always do a final minus an initial whenever we see delta. So how do we get this? in terms of the first one, the blue one, we did final, +3 minus initial, -2, which gives me +5. For here we do, how do we get -5? Well, we do final, -2, minus initial, which is 3, which still gives me -5. Okay, so this is the format. Whenever we see a change, we always want to take a final value, a final position, and subtract an initial value. So in this case, both the magnitudes of the distance and displacements would be the same. The directions obviously would be different with both circumstances. And if an object did something like this, right? In this case, my distance that I traveled was 2 plus 2 plus 5. So my distance I just traveled is 9 meters. Whereas now my displacement that I traveled is still going to be a +5 meters because it is simply a straight line from where I started to where I ended. Another example of when distance and displacement would be different is anything that's going to be in two directions. If we are going to start here at my initial position, I'm going to walk to the right and I'm going to walk down. Maybe this is 3 meters, this is 4 meters, right? And this is where I end. Okay, the distance that I just traveled is simply going to be 7 meters. My displacement, though, would be a straight line from where I started to where I ended. This is going to be my displacement. And in this case, we could simply use, because we created a right triangle here, we could use Pythagorean's theorem to figure out what my displacement is going to be. And this is a nice one. We have a 3, we have a 4. And so if we do Pythagorean's theorem, and we know some of the shortcuts, we know that we went 5 meters. And in this case, we still need a direction. So we're going to say never eat soggy waffles, right? Never eat soggy waffles. So our direction in this case is south. Oop, that's not a 5. That's a south east, right? We're not going to worry about the angle right now. We're just understanding that this is different than my distance, and I also have a direction. Now let's talk about speed and velocity. In our everyday life, these two concepts can be used interchangeably, and in physics they can be the same, but there are some very distinct differences between speed and velocity. So speed is a rate of change of distance with respect to time, and velocity is a vector that is a rate of change of displacement with respect to time. So notice that speed uses distance and velocity uses displacement. And because displacement is a vector, velocity is also a vector. Okay, so we're going to write speed is distance divided by time, and velocity is displacement divided by time. Now, can they be the same? Yes. If my distance is equal to my displacement, then my speed can equal my velocity. Okay. The one thing that we always have to make sure is that because it is a vector, we have to include a direction. Okay. So while our speed of an object maybe could be, I'm going to write it out because S is not actually standing for speed. Speed could be, 15 meters per second. Our velocity, if we are traveling at the same rate, could be positive 15 meters per second. All right, so both of those can tell us the rate of which we're traveling if our distance and our displacement would be the same, but we'd have to indicate velocity as a positive or with a direction.